vehicle. Okay, so like this. Mass, of course, will be the same. Mass always the same mass. Then W equal mg. So the moon have 1/6. So the weight also 1/6. Then the acceleration is same. Because F equal ma, F equal ma. You see, questions tell us force are the same. Mass are the same. So acceleration same, equal. This is the reason they are same. Okay, so next. Okay, moment. Okay, revise now. What is moment? Moment is turning effect by a force. So a force will give you turning effect if got support. Let's say the support here. Then force here will give you clockwise moment. Then another side, also another force will give you anti-clockwise moment. From pivot is the distance. Got 2. So F1 D1 equal F2 D2 when equilibrium or balance. Balance, you will have this. Then you need to see where is your support point. Then where is your clockwise and anti-clockwise. So this one F1 will give you what? Anti-clockwise moment. F2 give you clockwise moment. Then the distance like this, distance from pivot. Same thing, if equilibrium, D1, D2, F1, F2, D2, F2, D2. Okay, let's say we have another one, F3. This one also clockwise. So plus at the back for equilibrium. Okay, I must follow the direction to plus. Then we have look the question. Okay, see where is your support point? Pivot here. Be careful, pivot is here. So what's question give? Calculate this force. Then got 2 distance. But question give you pressure. Pressure in here. So we can get the force from here. Like this. Why I know is to the right hand side? Because your force by the driver is to the left, this one to the right. Why? Because one is clockwise, another one anti-clockwise. So we calculate the pressure equal to force over area. To get the force first, then the area of the piston, power -4. So your force is 325 Newton. So now we have clockwise and anti-clockwise already. So FD. By the driver, we don't know. Then the distance, 24. Always from pivot to the force. And perpendicular, 7. So you can see this. Your leg provide this amount of force. But the piston will have 300 something force. So our leg, small leg can have a big force by this system. Then stop your car. Be careful, this one diagram is the same but different question. You see this one? Give you the force here. Here don't have force, okay? So we can calculate the force in the tank. No tank. Piston, cylinder. Okay, so we use F1, D1, F2, D2. Force, we don't know. Then the distance, 8. Then force 200 multiplied 22. Everywhere is equal. Distance for 200, 8 for here. Because your force here, another force here to support, to balance. Actually, not just balance, increase. So the force on the piston 550 Newton. After that, calculate the pressure. Because question asks for the pressure. 550, 5 times 10 power negative 4. Be careful about the unit. This one is meter, so we can use Pascal. 1.1 times 10 power of 6. Pascal. Because meter. Remember to write the unit at the end, at the last. Okay, this one also moment. Okay, you need to know which one pivot. About B is pivot. Then what is P? P pivot to the P 1.5. So will be 1.5 P in terms of P. Moment of W. This one is 2 meter. So this one is 1 meter. Moment is force times distance. So it will be force. What is the force? 210 multiplied 1. So 210 Newton meter. After that, W will be anti-clockwise. P will be clockwise. Both are equal. Equilibrium is balanced. So P and W are balanced. 210 equal to 1.5 P. So P will be 140 Newton. Then W we will use upwards equal to downwards. So P 140 plus Q equal to 10. Why we use this? Because resultant force equal to 0. Equilibrium. So 70 Newton. So sometimes we will use the moment, sometimes we will use force to calculate. Okay, we got 3 forces. 3 forces. Currently only 1 force. So we use moment. Okay. This one also 1 force. So use moment. This one got 2 forces, 1 unknown force. That's why we use force. When we only have 1, use moment. When we have 2, use outward equal to outward.